Okay, hello, welcome to my channel. My name is Tolo Anch, and in this video we want to go into a set of numbers that is in fact beyond the real numbers. All right, so we say beyond. Well, it doesn't really mean further than. It just has to do with containing more numbers than the real numbers system. Right, so now when we talk about the real number system, okay, this is a system of numbers that consists of numbers from the set of rational numbers, let's say fractions, right, where the numerator and denominator are integers, and the denominator is not zero. It contains irrational numbers, numbers that we can't even express as in a fraction form, numbers like pi, e, and other, should I say, crazy looking numbers. All right, so the set of real numbers consists of every kind of number that, if you don't know about complex numbers, I would say that you can even think of. Right, so good. So when we talk about complex numbers, well, to really help us see what I mean when I say beyond the real numbers in that kind of style, right? Now let's start off by solving this equation. So suppose we to solve the equation, let's say x squared plus 4 equals to 0. So you want to find the value or values of x that will satisfy this equation. So from here we can subtract 4 from both sides. So say let's subtract 4 from the left hand side and then subtract 4 from the right hand side. Right, so when we do this, we're going to have x squared here, then 4 minus 4 will be 0. We equate it to 0 minus 4, of course that's negative 4. Good. So the question now is which numbers can we square so that we get negative 4? All right, or maybe let's take the positive or negative square root of both sides. So we take the positive or negative square root of the left hand side, that will give us positive or negative square root of the right hand side as well. Now, what is the square root of negative 4? All right, now negative 2 times negative 2 is positive 4. So the square root of negative 4 is not negative 2. In fact, we don't have a real number, so that when we multiply it by itself, we get negative 4 inside, so that this square root will give us a real number as a result. So what do we do? Well, so from here, this is where the thing gets, kind of impossible to get a real result. Of course, there's no real result that will give us this. There's no real number that we can square to give us negative 4. Okay, so can we just say that there is no solution at all? Well, there is no solution to this equation from the set of real numbers. That's why we have to try to see if we can go further. Right, now it doesn't work all the time that you can go beyond where you don't have a solution. For example, logarithm of 0. Okay, but let's see. Now we have here square root of negative 4. Now we know that if we multiply negative 1 by 4, we are going to get negative 4. Right, so I'm going to rewrite square root of negative 4 as 4 times negative 1. Good. So from here we can split this, square root of this times square root of that. Well, that works when the two numbers are positive, but we just use that property here. The square root of 4, of course, is 2 times the square root of, we put negative 1 here. Again, which number can we square to get negative 1? That's not possible, because the square always gives us a non-negative result. Right? Good. So in this case, I'm going to say, well, let's do something. Say let the square root of negative 1 be, let's give it an in addition, let's just call it I. So in that case, this will now become 2 times the square root of negative 1, but we are just calling it I. Right, so in that case, this becomes 2I. So if we allow this to just be some notation, right, we can write it as this, since this is not a real number. So with that, I'm going to call this this to be positive or negative. Well, square root of negative 4, we've written it as 2I, where the I is known to be square root of negative 1. All right, so let me put it out here, where this I here is the square root of minus 1. Good. This right here is the result. And in fact, the presence of this I, where the I represents square root of negative 1, of course, square root of negative 1 is not a real number, so it's more like an imaginary number, this I here, where you don't have a real number for it, you just decide to use some notation to represent this. You just, it's an imaginary stuff, right? So a number that has this imaginary notation, where we have square root of negative 1, is called a complex number. Now, sometimes this may not even be present, so we can still call it a complex number, and that is really going to make sense when we generalize this. So given that this is the case, okay, and we call this a complex number as a solution, or the complex numbers here anyway, in general, in fact, so let me put it out here for you. In general, Okay, oh, that's not a very good one. Complex number has the form a plus, and let's say bi, all right, where a and b are real numbers, where a and b are real numbers, the numbers we of course we know of real numbers, and then I here is the square root of -1 as we discussed earlier. Good. So this is the form, the general form that any complex number has. A plus bi, where a and b are normal numbers, right? Real numbers. Then this I is the square root of -1, since we can't get a real solution for that. So this form here, we call it a complex number. All right, that is a complex number. So what we'll do with that, I'm going to clean everything here. Then we're going to start off with this form and then see examples of complex numbers, all right, given real numbers a and b, and then from there we can go ahead to think about the parts that the complex number has. So let me just clean this right here. These are examples, all right. So this is the result we got. This is the form for a general form of the complex numbers where a and b are any real numbers, and then I here represents the square root of -1. Good. Okay, so as an example, the first one here we have 2 plus 3i. So you can say that a is the 2, b, which tends with the I, is 3, right? Positive 3, and then the I is here. So this is a complex number where 2 and 3 are real numbers, and of course we understand I to mean square root of -1. The second example, well, a is not this. Remember, the b is the one that stands with the I, so b is 1. The coefficient of I here is 1, right? Then a is -1. It's supposed to be positive a, but here it has a negative sign, so a is -1 for the second example. Then the third example, you notice that the first part here, there is nothing here, all right? Meanwhile, for this middle part, we have -2i. That is it here. So that means the a here is 0. We must spell it out for you. So we have a here is 0, and then of course b is -2. Here we say that a is -1. So okay, let it be like solutions, and then b is 1. For the first one, it's easy. A is 2, b is 3. Now let's do the last one. But you can notice that this third one, it's one of the solutions we had after solving that equation we wrote in the first part of the board. It's one of the solutions we had, plus or minus 2i, right, as our solutions. So what you see here is that this is still a complex number, even when this part that does not have the I, which we call the real part, even when it's not there, all right? Then the next example I'll give is this number 8. This is also a complex number. Remember, from the general form, we say where a and b are real numbers. And you know that 0 is a real number, okay? So if b becomes 0, which is a real number, we'll have 0 times I. Of course, that's 0. Then a plus 0 is a. So a is just a real number on its own. This number here is also a complex number. So in this case, you have a to be 0, and then you have b, in this case, you have b to be 0, and then you have a to be 8. This is also a complex number, and this is a real number as well. So what that tells us is that every real number is a complex number, not just for 8 alone, all right? You can write any real number as the real part plus 0 times I, which would be just the real part, which is the real number, all right? And when I say real part, what do we really mean? So let's get into the part, of a complex number. So any single complex number definitely has 2 parts, all right? The first part, so let me just put it out here as parts, of a complex number. So let's say we're given a complex number. So we're given a complex number, let's say a plus bi, all right, where a and b of course are real numbers, and then I is the square root of -1. So I don't want to put it down again. So given this complex number, then we talk about the real part of that complex number. Now the real part of the complex number. So let's say we call this complex number z. So given a complex number, let's call it z, all right? The real part of z, which we can denote by So I'm going to put it down here, denoted by, now, the real part of z. Alright, so this is the real part of this complex number is going to be, well, the real part of a complex number is the complex number is separate, is a number made up of sum of two terms. Alright, so the first term, that is the a plus bi. Now the term that does not have the I with it, that is a term independent of the I symbol, which represents square root of -1, is what we call the real part. Alright, so the real part of z is going to be a. That is because a does not have this notation, this I here, so it's called the real part. Now the second one is, we're going to have the imaginary part. I don't know why I like calling it complex part. Imaginary, the imaginary part. Alright, part of z, which we can denote by, now, just some stuff like that. Imaginary part of z is going to be what? Well, since the real part is the part that has that is independent of the I, that is without the I, of course you can think about the imaginary part to be this other part, right? But it is not the entire thing. It's not the entire thing. Rather, it is the real number that stands with the imaginary notation. That is the I, and that is going to be b. So given any complex number, the real part is the free part, the part without the I. Meanwhile, the complex part is a number that stands with the imaginary notation. So that I is called the imaginary notation. That's what we call b. Good. So let's look at a few examples on that. So the real part of, I'm going to denote it by, the real part of the complex number, let's say I, alright, -1 is going to be what? Well, the real part, the part without the I, this is the I, the part without the I is -1, so the real part of that is just -1. Alright, the second example, let's say the imaginary part of, so I'm going to denote it like this, the imaginary part of, let's say 8, okay, is going to be what? Well, the part without the I, this is just a number and on its own doesn't have the I. Sorry, the part with the I, that is imaginary part, this is just a number without the I, so the imaginary part must be 0. Look at this, the imaginary part, which we say should be b, alright, in this case is 0, so just easy. Okay, so you can choose any example, any random examples, that is any complex number, as I've shown you how to set it up by real numbers, and then one of them is attached with the I. Good. Okay, so I think that's a nice introduction into complex numbers, and from our next video, I would like to see how we can make use of this form to write the complex number using some other coordinates instead of just a and b, which are just real numbers. We can think about it as a way of locating complex numbers somewhere in some plane, and then getting a better or a more useful form for it, alright, which will lead us into a lot of other interesting stuff. Okay, thanks for watching. Please share this video with your friends, and we'll see you in our next video.